So there's lots of challenges that are happening in science at the moment. And I gave entire semesters, academic years. I talk about this a lot. I give lectures. We do hands-on workshops. This year, SIPS was here, Society for Improvement of Psychological Science. So hackathons, workshops where people together from undergraduate students all the way to full professors sitting together in a round table and hacking stuff together in order to get science done, which is very exciting for me because when I was a student, I did not have any of this. So I feel like if you're passionate about science, if you want to understand more about the world and how things function, this is a great opportunity, something that is happening now and we did not have before, and you can join us on this journey. So I saw a little bit of the slides that you had in the first week, and I will try not to repeat it, and I will try to take you a step further. I didn't actually know that it's going to be like this. I didn't know what to expect. So based on what I've been told, I prepared some slides. And the slides tell a story, and I share this story all the time because, in a way, this is my story of what happened to me when I started to do my PhD in social psychology. PhD actually is in a business school. So I did my PhD in management department, and then slowly I moved to social psychology, and then slowly I moved into open science, meta science. And as I was doing my PhD from 2009 to 2014, I realized a lot of challenges and things that are happening. And I want to share a little bit of this confusion and this story with you, and then tell you about the things that not only I realized about science, but all of us were trying to figure out together. Why are these things happening? So you talked a little bit about a replication crisis and BEM feeding the future, and Ioannidis in 2005 saying are all published research or most published research, is it false? So we want to get to some point of sharing a more optimistic, constructive story about realizing all kinds of challenges and showing you these challenges so that you will know how to overcome these challenges and do things better when you conduct your own research. So in the spirit of open science, everything that I do, you can scan and download the slides. If you can't catch the QR code, the links are going to be on the bottom. Yeah. I'm going to start with one fairly famous case study. So I'm going to talk about 3 case studies. This is the first of 3. 2015, we finally got the scientific finding that we were all hoping for. And the scientific finding is, scientists say eating chocolate can help you lose weight. Obvious is that there's a problem here. And what is this problem? The person who came up with this finding, this is a real study that was conducted on real people. However, the person who did this shared afterwards, after this blew up and became viral, and millions of people decided that they're going to eat chocolate instead of going to the gym. He came up with a confession, and the confession was, I fooled millions into thinking chocolate helps weight loss. Here's how. And already back then, I was having a little bit of doubts because of BEM, because of false positive psychology, but this really helped drive the message home to help me understand just how bad things are, not just in psychology, but also with health-related research. So he's saying, I'll read this out to you. Here is a dirty little science secret. If you measure a large number of things, but a small number of people, you are almost guaranteed, almost 100%, to get a statistically significant result. How did they do this? Real study, real people. However, our study included 18 different measurements: weight, cholesterol, sodium, blood protein, sleep quality, well-being, blah, 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 blah. They didn't report all of it. They just reported the thing that worked. On how many people? On 15 people. Now, if you have a very, very small sample, what happens? Very, very large error rate. And if you include a lot of variables, many of them fluctuate all the time. One of them will likely be a false positive of showing some kind of an effect. But this was not enough. What other things did they do? One subject was dropped. This study design is a recipe for false positives. So this is the first case study, and I think for the first time, the general public felt very deceived, and I as well. So I needed to get back my gym subscription and start doing all the things that I was doing. But then I became more cautious about all kinds of things. So I started looking out for all kinds of signals that things are not going as well as intended. So I'm going to give you 2 big case studies, not for the general audiences, not chocolate, weight loss, health related, but stuff from my field in social psychology. The first one is priming. I was talking about this in a talk that I gave last week in Venus. And I feel like this is a very important case study because there's a lot that you can learn from that case study. There's a lot that I gained from this case study about what should we look out for. So it starts from this paper. And this paper, you can't see this, but this paper is from 1979. And this is a very, very impactful study. How impactful? This says cited by something like 2,600. If you look at the distribution of citations, this is a very extreme outlier. If something has been cited 2,600 times, then this means that this is very impactful and it has led to a lot of more literature, more papers coming out from that. What did it do? It did something that's called priming hostility. So you do all kinds of magical things like unscramble sentences, and the people who were assigned to unscramble sentences with hostility seem to have some kind of behavioral impact at the end. They studied a whole bit about social priming. From there, studied a lot of follow-up papers, and this became, when I was a PhD student, this was the #1 thing that you wanted to do. Social priming is where you should go invest your resources, and probably will land you a good job at the end. What could go wrong with this? Over the years, we understood that we wanted to revisit this, and we thought, what better than to revisit one of the classics? We were hoping, we were quite sure that this is going to work out. So we embarked on something called a registered replication report. And we got a bunch of labs from around the world. You can see just how many labs. All these are names of different people in different labs from around the world. I think also in Hungary, there were quite a few people who joined us, right? And we got the author from Srull and Wyer, the author, to help us in order to vet the protocol, to make sure that everything is correct. And then we wanted to see, are we able to observe the same effect as in 1979 after all of these years in many labs from around the world? What we found was, although the confidence interval for one outcome excluded 0, one outcome, the observed effect was in the prediction direction. These results suggest that the currently used methods do not produce priming effect that is practically and routinely detectable. That is a very scientific jargon way of saying things didn't work out as expected. So this was a little bit confusing for us because this is one of the biggest findings in social psychology, in social priming. We were sure that this is going to work out. A lot of these people who took part in this expected an effect. So when we asked them before they ran the study, are you expecting an effect? They expected. And the person who was involved from 1979 said, yeah, this is the protocol. You should proceed with this. This is what you should do. And at the end, after a lot of measurements and a lot of things done in order to try and make this happen, they did not find support for social priming. So you should ask yourself, 2016, we see this kind of thing. What should you do with this? What does this mean? Does this mean that social priming doesn't work? Or maybe we got this wrong? Or maybe something about the process? Maybe it's been a lot of, many years, many decades. Things just don't work as much anymore. Now, we started a whole debate about this. I was very active on Twitter X. Now all of us moved to Blue Sky. But I started to capture a lot of screen captures from different debates. What was interesting is that Randy, so this is Randy here, is the person who ran this. So he's the first author. Randy over here is the first author. He wrote this. And he says, actually, after we ran this whole thing, I discovered a meta-analysis. And I looked very, very carefully at the meta-analysis. And this is what I found. Previous meta-analysis computed the effect size for Srull and Wyer to be a Cohen's d of 5.6. How many of you are familiar with Cohen's d? Few of you? Okay. Cohen's d indicates the magnitude, the impact of an intervention. So you compare the experimental to control. 5.6. How is this compared to the average effect in social psychology? So what is an average effect in social psychology based on your understanding? What you remember?
This is way larger than the average.
Yeah. So the things that you typically see, what is the Cohen's d that you would typically see in the literature?
It's good research. It's like 0 point something.
Yeah. So already lower than 1. Yeah, most of them are lower than 1. And then I will show you kind of like benchmarks of how to compare this to others. Anything that is larger than 1 is almost incredible. It's like too good to be. 5.65 is impossible. It's just unbelievable. Now, when we look at this meta-analysis, so we see a meta-analysis, we see another thing. How many participants were there in the entire study? 80. 5.6. All the other effects in the meta-analysis, much, much lower than that, lower than 1, right? And then we see some of them also have like a 1.04. However, when we look at this meta-analysis, perhaps you talked about it last week, we also see some familiar names. What familiar names do we see? Staple and. Who is Staple?
No, we didn't talk about Staple yet.
Staple is Diederik Staple. He was the Dean of Social Psychology in Tilburg University. And this is by far the biggest fraud case in the history of social psychology. So as the dean, he fabricated everything from his PhD all the way to becoming a dean. Dozens of co-authors, 60-something retractions. Most of these papers have been retracted. So when you have a meta-analysis, you have two problems. First, some effect sizes are just too large to be true. Impossible effects. Second of all, Did anybody check? Maybe there's fraud. After there's fraud, did anybody update the meta-analysis in order to see that maybe the meta-analysis is doing something differently? So already when we do this meta-analysis, we see a lot of signs that something very, very wrong is happening over here. So in order to try and explain, Randy was trying to explain to people on Twitter, what is a coherence D of 5.65? So he was comparing this to, you can't see this, but Shaquille O'Neal, the height of Shaquille O'Neal compared to the average female. Shaquille O'Neal is a famous NBA star from my time, long time ago. So it's a very big distance from 2015 centimeters to 165 centimeters. So trying to show that this is a problem. So what did they do? They contacted Bob Wyer, who was the same person here who vetted the protocol, same person who did the study in 79, and they asked him, so what is going on over here? And Bob Wyer was looking at this 50 years later and saying, oh, very likely that this is a mistake. 2,600 citations over 50 years, only after a mass replication effort, and somebody looking carefully at the meta-analysis, suddenly we realize probably this indicates a mistake. This is a big blow for us. And as much as this is funny, for us, this will cause for crying because a lot of us wasted many, many years in trying to build on this literature. If you want to know what is a coherence D and how big this should be, we actually have a collaborative guide. You can join this guide. You can become a co-author if you want. So I started this with a bunch of, these are two of my students. Then we got people from Psychological Bulletin who are very, very good with stats. And together we built this guide for effect size and confidence intervals. And it includes a R code, and you can calculate any effect size and see how good it is. It's too small for you to see, but some of the benchmarks show that a small effect in social psychology is 0.15, a large effect is 0.65. So when you see something that's higher than 0.65 in social psychology, you should think very, very carefully how reliable, meaningful this thing is. When you see 5.6, you should stop, reevaluate, and then look for some kind of other evidence. Either this is fraud, this is a mistake, or something very, very wrong happened over there. Right? In addition, yes, please.
What do you think the reasons behind the fact that no one noticed it for 2,000 publications and citations?
Good question. I would like to open this up for debate after I show you another case study, another amazing case study. After priming, we have another one that is even more baffling, just blows your mind how after all these years, nobody has seen this. In addition, this looks like a very regular figure, right? Something that you would see normally, especially in old articles. What is the problem with this figure? If you take a moment to really sit and watch this very, very carefully, this looks too perfect. After some time, when you start looking at these figures, you look at this and it's like, everything is just going in the right direction and the gaps are very nice here and everything goes according to plan. Why is this almost too good to be true? Because what was the sample size? So if we go back to this one, the sample size was 80. When you have 80, what do you expect? Very large deviation. So if you have a lot of conditions, you would expect something to go a little bit off over here. I will just read to you one of the tweets. The four-way interaction among those variables was also significant, p-value lower than 0.02. So if you have something with 80 participants that looks a little bit like this and a p-value of lower than 0.02 with a four-way interaction, sometimes for me it's difficult with a two-way interaction. Three-way interaction, if I really sit on this and I try to concentrate there, maybe I can get four-way interaction that they say that they predicted in advance, p-value just below 0.05 and produces a figure like this. Too good to be true. This is nearly impossible. We should not take this for granted unless we were able to confirm this with many replications from around the world by independent labs. So people were saying, did you look at the figures? The figures now also don't make any sense. And this only happened after we invested all the time in doing the replication. So people are like, yeah, this doesn't make any sense. Something went very wrong here. So just to show you how bad this thing is, in Srull and Wyer, what is the effect size? 3.01 for one of the measures. How many participants in each condition? 8 and 8. How about all the other labs? So this is a meta-analysis of many labs. Here is the 0. And these are the effects with the confidence intervals. So most of them, aside from one maybe, overlap with the null. And at the end over here, we have this diamond, which summarizes all the meta-analysis of all of the labs. And the meta-analysis shows that the effect is 0.08 coherence D. So 0.08 coherence D is very, very different from 3.01. And not just one measure, we have a lot of measures like this. So for example, here we have 2.99 minus 0.008, so it even goes in the other direction. And here there's like all of them overlap with the null, and one is pointing in the opposite direction. So After all of this, you have to ask yourself, what happened here? We need to have a discussion. We need to sit all together, maybe with the original authors, maybe with the journal editors. We need to understand, how did this happen? Now, today, we have a fairly good understanding of how to do this kind of discussion and what the outcome of this discussion might be. However, in 2016, what is the initial reaction from the community? The original authors did this correctly. All the replicators did this wrong, which for me is just mind. How could it be? Especially since we saw the figure, we saw the impossible according to D, we saw all of these labs, the experts in the field working together. Why would you emphasize the first one to be better than all of these other labs doing the other things together? Vetted by the protocol, vetted by the original. Why would the first one be better? Why? Because it was published in a top-tier journal. So people are like, this must be true. The replicators don't know what they're doing. Right? So then came a criticism saying the people who did the replications didn't know what they were doing because this was 50 years later. They don't have a good understanding of the methods. If they would adjust it to nowadays and they would work together with the original authors to adjust the methods, then everything will work out. So if you remember Randy, who did this mass replication, wasted 2-3 years of his life only to later see all of the problems in the meta-analysis, what did poor Randy do? He did another mass replication. So he embarked on a second one with a lot of authors from all around the world, and they did two things. First, they ran exactly the same thing with a direct replication. The second one, they worked with original authors in order to try and adjust this for today and get all of the feedback and incorporate this. So they did a direct replication and a conceptual replication. And we thought, okay, so maybe we can get social priming to work. However, at the end, what happened? The hostile priming effect for both the close replication and the conceptual replication is not significantly different from zero, and if true effect is non-zero, we're smaller than the most labs. Despite our best efforts to produce favorable conditions for effect to emerge, we did not detect a hostile priming effect. Big jargon scientific language to saying something is very, very wrong here. We couldn't get this to work. We've wasted millions of dollars with many, many labs from around the world doing this twice. For one study that was done with 80 participants in 1979 and had 2,600 citations. How did all these articles since then manage to find this effect again and again when we can't get the basic one to work? Not just with the original method, but also with the adjustments. So no one noticed for decades. Obvious errors in reporting, impossible effect sizes, figures too perfect. There's no, even after now, you go to JPSB, you go to this paper, no retraction, no error correction, no indication that there are replications. If you look at rates of citations, what gets cited more? The 1979, not the two papers that came out with the many replications. No systematic replication and validation all this time afterwards. So priming literature, we have a lot of case studies, not just hostility. We've done this with commitment, honesty, intelligence, death priming, and the very famous elderly priming with John Barge from 1996. Again and again, we just failed to find any support for social priming. And the devastating thing for me when I was at University of Hong Kong, every year, there's another student that decides to waste either 1 year as an undergraduate master's student or 4 years of a PhD in doing something based on social priming, thinking that this is going to work out. And at the end of the 4 years, when they don't find anything, they think they're bad. When I was doing my PhD trying to do this kind of thing and I couldn't get this to work, I didn't think I didn't think that the original was wrong. I was messing things up. I'm incompetent. This is because of me, because I don't know how to do science. I never even questioned the original finding. So for me, just seeing all of these things with all these mass replications, it's just like, I don't know what to make of this. 2016, my first year of a postdoc. What should I do with this? I really don't know. So I wanted to show you one of the possibilities of how can it be? What could happen to create an entire literature where people find positive results, so p-value lower than 0.05, even when there's nothing there. So I think back in 2010, 2011, 2012, when I was doing my PhD, we didn't have the tools to visualize this, so it was difficult to explain what could be causing this kind of thing. But now we call this p-hacking, we call this questionable research practices, and I want to show you just a small demonstration of some of these with a tool called p-hacker. So it's going to be a little bit small, and I can see the resolution here is not great. Yeah, okay. So what I will call out what's happening here in this. So this is a simulation based on R. So the nice thing about R is that R also has Shiny apps, and in the Shiny apps, you can output for people who know nothing about code. You can create a nice interface where people can feel the statistics and feel the numbers and feel all the things in order to demonstrate something. So this shows you how to do p-hacking. So here, for example, you have the name for experimental group. So in this case, we're going to put in, let's say, priming. And control group is going to be called control. Initial number of participants in each group, we can put this at 8. I'm going to leave it at 20, just to make it a little bit better than the primary effects. What is the true effect, the Cohen's d, the real effect? I'm going to set this at 0, meaning that anything that comes out of here is going to be complete noise. Nothing should come out as being meaningful. All of this is just going to be simulated numbers altogether. And then here, number of DVs, we're going to do this a little bit like the social priming or the chocolate study. We're going to increase the number of DVs. So I'm going to put this from 4 to 10. And we're going to run this experiment. So I'm just going to put in some number, and I'm going to run this experiment. So what R is doing right now is simulating 10 different dependent variables based on absolutely random samples. So Cohen's d should be 0. You should not find any kind of support for anything. However, if you look at this, you can see a bunch of numbers. This is dv1, dv2, dv3. You can see the stats here. You can see the p-value, and you can see whether this is significant or not. Already, when you sample 10 of these dependent variables, just based on the randomness of the universe, you can already see dv7 in green is getting very close to significance. So you can see here, p-value is lower than 0.10, right? So this is 0.085. It's not lower than 0.05, but it's getting very, very close. So one of the things that we can do, a little bit like with the chocolate study, we can look at the participants. So it gives me like a whole plot here of all the participants there. And then I look at this participant over here, which is outside of this range. And I think to myself, oh, I remember this day he was not feeling well. So I'm just going to take this one out here. And then I go back to DV number 7, green. So we have p-value 0.043, which is amazing because now I can publish in Science and Nature and get my career and get promoted, right? So this, I think, even when I was doing my PhD, we had some kind of an understanding that doing this kind of outlier exclusions, something is wrong about this. But I don't think this is what happened with BEM, and I don't think this is what happened with social priming. So what we're going to do is we're going to assume best practices at the time, and we're going to bring this guy back, okay? Instead, what I want to show you is something that we didn't know that we shouldn't do in 2010. We're going to do this kind of p-hack. So there's another tab here. We're going to move over here. One thing that you can do is that you can control for many variables. You can control for social status, age, gender, and this can play with the p-values until you can find something, so you can decide what you want to control, and you can see all kinds of changes in the p-values. But I'm going to leave this. What I'm going to show you now is something called optional stopping. What's nice about this is that after you had 20 for each condition, I'm going to add 5 more, and then 5 more, and then 5 more, and then 5 more. And then I'm going to show you something. This phenomenon is called the dance of the p-values. They go up, they go down, just by the randomness of the universe. And because we have 10 variables, at some point, at the end, we're going to find something that is going to be significant. Okay? So let's do this together. You need to watch these numbers. Just watch the p-values as much as you can see from far away. See just what happens when we add participants. I'm going to add here, add 5, but I'm just going to take the controls away. Okay. So I'm going to add 5 participants. When I add 5 participants and I look at DV7, suddenly it has nothing to do with lower than 0.1, right? Suddenly it goes to this. So now I'm really worried. Maybe I'm not going to be able to publish anything. So I'm going to keep doing this. So now we're at like 50, 60, 70. So every time I collect data and then I look. I collect data and then I peak. I collect data and then I peak. And after I do this for a while, this is already 100. 110, 120, I keep going. Now, after I collected 130, suddenly this one up there, it starts to look a little bit green. So maybe we're getting closer to this. I'm going to add 5 more. Okay, getting even more significant. I'm going to add 5 more. Oh, now I can stop and I can say, this is amazing. I can already publish. DV number 1 is showing p-value lower than 0.05. Right? So the only thing that I did is that I had a lot of variables. I added optional stopping. Every time I collected, I looked, I picked, and then if it's not lower than 0.05, then I continue. Seems like when we have podcast interviews with Daryl Bem, that this was best practice at the time. You just, every participant that comes in, or you just check your stats. Oh, okay. Bring another participant, check stats. Okay, still not. Okay, bring another one. So many people, including at that time, were doing these kinds of things.
So if I know it right, you cannot do this forever if you're getting too far in collecting data, and so you will eventually get really close to the true effect in your data, right? So you can only do this for I don't know, for the first few hundred participants, and you might expect the p-values to go down enough. But if you're over that, like that,
yeah. So when the small samples, you still have the dance.
Yes.
over time, the more that you have, you're going to get closer. But if you have enough dependent variables, and if you split the adding participants to 5, or if you split it to 1, you're almost guaranteed by the time that it flattens out, you're going to be guaranteed to find something lower than 0.05. Actually, you can keep going with this until you find like more than 1. So at some point, there's going to be perhaps, at some point, something is going to come out significant. So now we've got DV number 9. DV number 9 suddenly becomes significant. And when I'm telling myself, okay, maybe I can like do more than just the 1 DV, so suddenly DV number 5 starts to get significant, and I don't know, it's just if you keep going with this, oh no, suddenly I have 2 DVs that I can publish with because nature needs 2 DVs to be significant. So the only thing that I did is just adding more and more participants and capitalizing on random chance. Is this clear what I was showing you here with the p-hacking? Very disturbing. All of us were doing this at some point in the 2010s, but then false positive psychology came out, then BEM came out, then we understood that the way to do this is every time you peak, you need to compensate by reducing your alpha. So you start from, let's say, alpha p-value lower than 0.05. If you peak once, you divide your alpha by 2. So if you peak once, then the p-value you should aim for is 0.025. If you peak twice, divide this by 2. Peak 3 times, divide this by 2. So every time, because you increase your chances of finding something, you should also compensate with the p-value. Okay? There are other methods to do this, but this is like broadly there's also, because we don't have time, there's also other ways to p-hack. You can go and have a look at these, but we're going to make some progress and look at so the main question, after we realize this whole thing, the question is, are people really doing this? Did people do this in the 2010s? And what is the best method to know whether people are doing this? So you can apply meta science in order to look at the literature. We'll talk about this. The second thing that you can do is very straightforward. You can just go to people and say, are you doing this? Are you doing optional stalking? And whenever you ask people whether they're doing something that's bad or misbehaving, you expect to have very low rates. So what is another question you can ask? Not you, you're good, but people around you. People around you, are they doing something bad? And then you can have some kind of an analysis to try and measure what is the likely rate based on what people are self-reporting and then what people are saying about what's happening around. So here you have a lot of questionable research practices, failing to report all dependent measures, just like the chocolate study, just like in social priming, failing to report all conditions and all that. How many people are doing this based on our estimates? So the first one that came out in 2012, where we asked people, 78% are not reporting all dependent measures. It's crazy. 72, 42, 36, 39. So if you aggregate all of this together, it seems like people, on average, at least one of the questionable research practices, how many people are doing this? Close to 100% people are doing this, which is very disturbing, which starts to answer the question, how could it be that 2,600 citations, all of them found support for something that doesn't really exist? The most troubling, perhaps, is that all of this you can say, okay, ignorance, we didn't know. But here you have falsifying data. What is the rate for falsifying data? So people self-report something like 2 to 3%, which is already terrifying. And then you ask people, how many people did you see around you that are falsifying data? So if you're in a lab, your PI or other people in the lab, and it goes up. And then some people are saying, 30% people saying that they saw falsification. So if you adjust for this kind of thing, 9%, 1 in every 10 studies is going to be falsified data. That's not good. But we did this. Does this replicate? We should also run replications of this, right? So we should ask more people, not just this kind of thing. So we've been asking for over a very long period of time students whether students are doing this. And I can tell you for sure from the stuff that I've seen at University of Hong Kong, top students, Ivy League, Asian University, students are doing this for sure. And then all kinds of other things that are happening when we aggregate all of this together. I'll show you more findings. Another thing that we can do is that we can meta-science all of these findings. What can you do? There's a whole distribution of p-values that you expect if there's a true effect. If there's a true effect, you should have a lot of findings with p-value lower than 0.05, a lot of this, and then a little bit less, 0.002, a little bit less, 0.03, a little bit less, 0.04. This seems very natural. What doesn't seem natural? Suddenly, when you look at 0.05, there's a big jump over here. Why is there a big jump in the literature here? It was supposed to go down a little bit further. Why is there a jump here? Because people understand that 0.05 is what gets them published. So they push their findings to find the 0.05. So with meta-scientific evidence, when you aggregate 258,000 test results from 30,000 articles, then you can see this kind of pattern and you realize people are doing something very, very fishy here. 0.05. So you can ask people and you can meta-science what it is that they're doing based on the literature. In the Netherlands, this is the year 2020. So after Diederik Stapel, after all of the Netherlands revamped everything and went all full on force in order to try and clean their act. How many people are saying that they're doing fraud? 4.3 and 4.2 in the Netherlands after Dietrich Stapel case. How many people are doing QRPs? More than 50%. This is 2020. This is not 2010, 2011. And this is the Netherlands, which we consider to be one of the, the front runners for open science in the world. Very disturbing. Daniel Lakens has an amazing book. He aggregated all of the replications. So all these are replications for how do people self-report doing questionable research practices. So look at just these rates of people just saying that they're doing harking, people that are doing that, they're excluding all kinds of measures, how much people are doing. Some of them gets very, very close to 60%, 70%. This is 10 years after Dietrich Stapel, 10 years after the self-reporting. We're not learning anything. When we aggregate this and we look at replications, we have very strong evidence that people are playing the game of science in a way that shouldn't be played, right? Now it's no longer ignorance. This is not because we don't know how to compensate for optional stopping. This is because we want to play the game of science and get published and get promoted and get hired, right? How much does it cost to pursue a finding that doesn't replicate? So you can already imagine poor Randy with 2 mass replication efforts from participants all over the world, researchers all over the world, just trying to think about how much this costs. We're talking millions. And this is in social psychology. This is an example from a tweet about what it costs for a medical finding to be irreplicable based on a scientific error. Billions, $1 billion spent chasing a flashy, unreplicable finding, and there are many examples of it. $1 billion, US dollars, the stuff that we can do with $1 billion US dollars. I get a hard time just finding any kind of funding for the kind of things that we do. So 1 billion is unbelievable. Ego depletion. How many of you have heard of ego depletion? Some of you have? Okay, good. So I just want to give you a sense of how big this literature is. It even exceeds to some extent social priming. So how many are we talking about? So I did this a few years ago, and you can see number of papers, 730. Number of citations, 57,000. There's a tool called Published or Perish. You can put ego depletion or Baumeister or something, and you can see all of the papers that come out of it, how many citations, and you can see just thousands of citations. If social priming had 2,600, the ego depletion from 2000, I can't remember 1998, had 6,000 and 2,000 citations. I'll just say very, very shortly, what is ego depletion? It's the idea that self-control, willpower, is a limited kind of power. So you can use up your willpower. The more that you use it up, the less that you have left. So if all day you're surrounded by all the other students and your classmates and the professors, and you deplete more and more depletion of self-control because you have to behave and you have to be nice and you have to smile. At the end of the day, you're completely depleted. So finally, you go home to your loved ones, the people that you want to spend time with the most, and then you snap. Something very, very small, something very tiny that happened. And it makes absolutely no sense because you've waited all day to be with these people. So why do you snap? So the idea is that it gets depleted. Another idea is you can train it. So unlike intelligence and unlike self-esteem and all the other stuff, self-control you can train just like in the gym in order to make it bigger so you can increase the pool. This is the idea, and I think it's very, very appealing. Back then it made a lot of sense to me. But self-control, willpower is a big force, and it was the promise of social psychology that finally we can tell people what they should do. They should go to a willpower gym to train their willpower, their ego, right? So 2010, and this is about the same time that I went to Florida State to work with Wyer. I was sure this is one of the biggest findings because we have a meta-analysis, and in the meta-analysis you can see Cohen's D, a much more reasonable Cohen's D. It's not 5.6, but when you do a meta-analysis of the entire literature altogether, you see a Cohen's D of 0.62. 0.62 is a reasonable effect, but it's a very large effect. So if you remember the benchmark that we saw from before, a large effect in social psychology is 0.65. This gets very close. If you compare it to many other things, it's much higher than those. This is 2010, but then started a lot of indication that we have problems with false positive psychology, Dietrich Stapel, all these things that started to come out. Most published findings are false. So we thought, what could go wrong with a meta-analysis? The thing that can go wrong with a meta-analysis is that meta-analysis is done on the literature. And if we don't have a good representation of the literature, or if the literature is very, very biased, so they only publish p-value lower than 0.05, or like we saw with the meta-analysis, some of the meta-analysis includes fraud, or some of the meta-analysis includes things that were p-hacked. Perhaps we should compensate for this in some way. And in 2010, we didn't know how to compensate for this. But 2013, 2014, people started to come out with a new method for meta-analysis to do publication bias assessment in order to see, is there something very, very strange about the literature that the meta-analysis is trying to summarize? Maybe there are a lot of findings in the file drawer, things that people are not submitting to publication or things that are getting rejected from the journals that we are not seeing. The problem is we don't know about these because the only thing that we can do in a meta-analysis is that we can write a call for papers. We can say, please send us all your findings. And sometimes people say this, but sometimes they don't. Even if they see this, maybe they don't want to share this. Maybe they feel like me, that they're incompetent. They just don't know how to do ego depletion. So maybe something is off, so they shouldn't send this to the journals. So generally what you end up doing is just summarizing the published literature, right? Which is very, very tricky. So first paper that started to come out, try to compensate from 0.62 to a publication bias adjustment. So they did something like put this in a funnel plot. And a funnel plot, I will show you in a second what that looks like. But looking at this funnel plot, for people who know what a meta-analysis is, and I will try to show you how to look at this. They look at this and instead there's something very, very strange about this funnel plot. This is not the way that you should see the studies in the funnel plot because this looks like a publication bias. What does it look like? It looks like we're only doing a meta-analysis on publications that have p-value lower than 0.05. Okay? So we're missing a lot of studies that should be there just because of the randomness of the universe and because of error rates. Right? We should see a lot more of these things that p-value higher than 0.05. So somehow there's some indication that there's a publication bias that is rejecting all of the things that are not p-value lower than 0.05. Okay? So this is the first paper that came out in 2014, looking for all kinds of other, so we developed all kinds of other measures like PET, PEACE, other kinds of things in order to see what happens if we try to simulate this. We don't know what these studies look like because people are not sharing this. Let's try and simulate this statistically to see if we simulate the missing studies, what does the effect look like? And it seems like each one of these methods offered a different way of compensating for this. And once you start to compensate for this, it goes down from 0.62 to much, much lower than that. So already people who had a lot of trust in this meta-analysis and in ego depletion working from 0.62, suddenly they understand it could be a lot lower than this, right? Another paper comes out of this, 2018. So this is a lot of people trying to figure out when we look at the literature and we do a meta-analysis, what should we look for? Okay? So now I'm going to show you another tool. And I strongly encourage you, if you're doing a thesis or you're doing any kind of research, before you embark on doing something based on a literature, just try and take all of the statistics and put this in this tool in order to see what is the indication that perhaps there's a publication bias. So the nice thing about this is a Shiny app, and it's meant to be able to help you, even if you don't know how to code anything, to take an entire literature, put it in there, do a meta-analysis, and check for publication bias. Okay? So this is what it looks like. So this is p-checker. It looks a little bit like the p-hacker. What we have over here is that, so before that I was sitting in a lab and I saw that somebody was working on a computer with a sticker that says stat check. So now we have all kinds of tools that help you to automatically extract all of the statistics from a PDF in order to show you everything that happened there in terms of the numbers. So you can see that you can apply stat check, or you can extract, or you can put this manually. All of the statistics, so T, degrees of freedom equals something, chi-square, correlation, ANOVA, or even if you just have a p-value. You can insert all of this over here. Once you insert this over here for an entire literature, you have here some simulations, aggregation, a summary of entire literature that would help you to gain some insights. So the nice thing about this is that some good people already uploaded some demo data, so I can show this demo data to you, and you can see that there's all kinds of things, like for example, this is ego depletion, or for example, this is elderly priming. So I'm going to use the elderly priming because we talked about priming, and Lakens did this, so I know this is a good summary of the entire literature. So if we press on this and we go back here, we can see that Daniel Lakens took all of the statistics from all this priming regarding elderly, put it over here. Where is this from? What is the statistics? What is the F value for this ANOVA? And what is the P value? And the nice thing that StatCheck, for example, does, and you can also check over here because this already includes StatCheck, is you can check whether the P values are correct. So one of the things that is happening is that actually a lot of researchers mess up. So when they write the statistics and the p-values do not match. And one of the nice things that you can do with automated tools is to check this. Is there some kind of indication for a problem? And with some of them, there's an indication for a problem, but it could be that maybe they use a one tail instead of a two tail, or it could be that they rounded something. But at least it helps you see in red something that you should check. This is already a nice first step. Another thing that you can do is you can do a meta-analysis. And it's amazing because it used to take a very long time for us to be able to code or calculate what is a meta-analysis. And here you can already see this is a meta-analysis of the social priming regarding elderly. And here you can see, once again, if I zoom into it even further, this funnel plot. So this funnel plot, you have something at 0, and around 0, you have one triangle. So if there's no effect, all of the findings should appear here. Then you have the findings for the meta-analysis, which is 0.5. So you can see what happens with this triangle around 0.5, which is what the meta-analysis is showing. And you can see some dots here, but usually you would see all of this triangle having dots all over the place, just by the randomness of the universe. So if you have dots here, but you don't have dots with the overlap with the 0, then it means that there's some studies that are missing over here. Right? So this is an indication for somebody who knows a meta-analysis, something very fishy is happening here, because all of these dots are just outside of the triangle of 0. But just by the randomness of the universe, we should have a few here, and we don't see that. So how can we see actual indications for this with statistics? So here we can see this is the summary of the meta-analysis. So this is actually a Cohen's d of 0.50, not too bad. But then all these P's, all of these publication bias adjustments, you can apply them in order to simulate these missing studies. And you can see that when you do this, it seems like there is no effect at the end. So it drops down from 0.50, it drops down to 0.03, or it drops down to 0.28. It depends on which kind of publication bias adjustment you're doing. But generally, it seems like it drops from 0.5 to 0.03, something like that. Okay. So this is already a very useful tab because it allows you to see all kinds of things. Another thing that you can have is a p-curve. And a p-curve is very interesting because it shows you what we would expect from p-values and what we actually see. So the green one here is what you expect the p-values to look like. Most of them under 0.01, then a little bit less 0.01, then a little bit less 0.02. But what you can see with the elderly priming is that most of the findings are just below 0.05, so 44%. So there's some deviation from this green one, right? And then there's some statistical inferences. So p-curve gives you a statistical analysis of this, and it shows you how likely is it that elderly priming actually has some evidential value. No support for evidential value. If there is some evidential value, is it inadequate? Definitely an indication that this is inadequate. Something very, very wrong is happening here. Studies lack evidential value and were intensely p-hacked. P equals 0.028. So just looking at this, based on p-curve, something very, very fishy is happening with priming. And you can do the same thing here with the self-control, with ego depletion. And you'll see that just like before, 32% are just 0.04. So the thing that I would suggest, if you're planning a thesis, go through, use publish and perish, look at the top literature, extract automatically with StatCheck, put everything over here on the left, and immediately you will get some indication of, is there a publication bias? Is this solid, not solid? Should I pursue this or not? This seems like a very logical first step. Any questions about this? Okay. All right. So if we go back to what these funnel plots should look like, if there's no effect whatsoever, it should all look a little bit like this, right? So all over the place in around the triangle of 0. If you discard all the non-significant results, the only thing that remains is here. And this looks very similar to what we saw with the elderly. And this looks very similar to what we saw with ego depletion, right? So after all, if you exclude all of these non-significant, then you would get something like 0.53. So all of these are left out. All of these perhaps were not submitted or were submitted and the journal said not interesting because we don't publish anything that is null finding. So the only thing that gets published are these ones, but they don't represent the entire literature. So just think about it. 2,600 citations for social priming, 6,000 something for ego depletion. These are the published findings. Can you imagine how many studies there are? Assuming that there is no p-hacking, assuming only publication bias. Just imagine how many studies are there that were conducted and nobody was talking about, nobody was submitting those, nobody was accepting this for publication. A big problem in science that we're not publishing. So what happens when we start doing things the right way? When we move from something with no pre-registration, with no open science, with no indication for adjusting, publication bias and all of that. What happens when we move from that to best practices open science, pre-registration? Then you move from a very messy literature to a much cleaner, something that seems more like what the results should be, and then it drops from 0.3 something to 0.04. So this is another example of money priming. So money priming doesn't seem to hold up when we use best practices of open science. Right? So these are the people who did the p-curve. I think you'll talk about this later in the course. If there's no effect Cohen's d, then it's 20-20-20. If it gets a little bit stronger, then 32-21, and then it drops. But the stronger the effect is, the more likely that it is to show more survey results under 0.01. So if you know something about the likelihood of a real effect, then you can compare this to what it is that you see literature, and then you can see if there's a deviation for that. So what happens when we p-curve the entire ego depletion literature? Then we see that actually the effect sizes drop to almost nothing. There's a big indication for a p-curve problem here. So this is like a summary of the journey that I went through. Devastating journey from 2010, when I thought this is the solid thing in social psychology. We started from meta-analysis 0.02, and then we did some peace, all kinds of things in order to see compensation. And then we started doing, okay, so we need to do our replication. When are we going to do our replication? And then it started getting closer and closer to 0.0. So after we saw all these meta-analysis, the only solution for this is we just need to repeat this. We have to do this as a mass replication. So we did a mass replication. 23 different labs from around the world who are experts in ego depletion, have been studying this again and again for decades, have come together in order to do this kind of thing. What did they find? Instead of a Cohen's d of 0.6 something, they found 0.04. So I didn't know what to think about this. What is this? What is happening here? I wasn't really sure. I was looking at all these noisy findings, like it's all over the place, some of it positive, negative, most of this overlaps with that all. Don't know what to do. Then all these big headlines started to come out. Everything is crumbling. The end of ego depletion theory, replication project. I don't know. It was a very, very dark times. And then another person came out with another ego depletion failure. Many labs, 3, failed to find more of that. So 2 big mass replication efforts failed to find something here. Then another one in 2018. So same person who did the meta-analysis did the mass replication effort, and it went from 0.62 to 0.04. Biggest finding in social psychology, right? So this is around the time when I was a postdoc, 2016. I didn't know what to think about this, but I was looking up to some people in the field to say, what are you saying about this? And this is Michael Instedt. Michael Instedt is one of our top researchers. Now he's a big advocate for open science, and this is what he wrote. So this is somebody who's been doing social psychology and ego depletion for a very long time. I've spent nearly a decade working on the concept of ego depletion. I have been rewarded for this work. I'm convinced that the main reason why I get invitations and all that is because of this work. The problem is that ego depletion might not even be a thing. So he's contemplating this, and what is the consequence of all of this? I'm in a dark place. I feel like the ground is moving from underneath me, and I no longer know what is real and what is not. And sometimes I wonder if I should be fixing myself more to drink alcohol, thinking maybe I should leave the profession, consider drowning themselves in booze and leaving the profession. And these are our top people. If you want to hear Michael Instedt talk about this, he actually had a podcast. He left this podcast, but it's called 2 Psychologists, 4 Beers. And it's heartbreaking. Whenever I listen to this and I play it for my students, I have like tears in my eyes because it's horrible that somebody who has spent over a decade and have found things and have published based on this is now saying maybe it could be that this is not a thing. So I strongly recommend these episodes are just mind-blowing. Now the question is, so what about Roy? Because I know this person and I know that he does good work and I know that he's a great thinker and I know that he's done some great contributions. So what is his response to all of this? So I was looking to see, Roy, please tell us what is happening. And you can see Michael Instedt, the same guy who was wanting to considering drowning himself in booze, meeting Roy Baumeister, discussing this in 2016. And this is Roy Baumeister saying, but there is no fix. I'm sorry that those people went through all this work. It's going to make it harder to get funding, and it has a weird effect on the literature too. That's too bad. But in terms of changing my thinking or shaking my faith in ego depletion, no. I am convinced, Roy is saying, I'm convinced that ego depletion is a real thing. Even after all these people, experts in ego depletion, can't find an effect for this. So here's another episode where he meets Roy Baumeister. Go and listen to this as well. This is his public response. And he says, forget about these people. We, Roy Baumeister and Kathleen Voss, we will organize a mass replication effort to show you that ego depletion is a thing. And I thought, okay, this is in good hands. We just need to wait for Roy Baumeister to come out and show us that ego depletion works. So they would say, we will organize a multi-site application. For 2 years, we were waiting for this. Kathleen Voss was working very, very hard on this in order to show the entire world that this is the case. Finally, look at all the people involved in the second ego depletion effect. What is the final conclusion? Found a non-significant result, D equals 0.06. First one was 0.04. Devastating stuff. Then they applied all kinds of things with Bayesian analysis and all kinds of fancy statistics. At the end, the original authors that said that the first ones did not do a good job, they did this again in things that they chose with their labs and their analysis. Still to find support for ego depletion. So for me, at the end, I'm just like, I don't even know what to think about this. And then some of the students at University of Hong Kong said, wait, but some people who came out from Hong Kong, so for example, one of the head of the department where I was, a multi-lab replication of ego depletion, they found something. They found support for an effect, right? A small but significant ego depletion effect, D equals 0.1. D equals 0.1. What does this mean? So they found support for the effect. Should I be studying this? Should I do my PhD on this? So I just want to tell you that now you can do a good analysis. We didn't use this before, but we can do a power analysis to see, in order to study this effect, let's say that you found significant, after you aggregated a lot of studies, none of them are significant, but one of, when you aggregate all of them together, then it becomes significant. But the effect is still 0.04, 0.06, 0.1. What to do with this? So go back to our confidence intervals and power analysis. We have a whole guide based on this, and these are our benchmark. If you do, based on this, a power analysis, you can use G-Power, or you can use our library called PWR. How many participants do you need in order to detect an effect of 0.1? This is what you need. You need 2 times 2 conditions of 1,200 participants. So in order to find this, you need 2,500 participants. This is not the strongest finding in social psychology. I would not recommend anybody to pursue this kind of thing because the likelihood of you being able to get this kind of sample, the amount of money that it would cost you to study this kind of thing is negligent. This is not worthwhile. So a lot of issues here. Very similar to social priming, but even worse than this because we have meta-analysis, because we have indications for publication, but because we repeated this again and again, and the original authors did this kind of thing and failed to find support for this. So all this is to summarize for you that we have some challenges. Even when you read something in the literature that has 6,000 citations for ego depletion, 2,600 for social priming, it doesn't mean anything. You need to critically evaluate these findings. One thing that you can do, look at the figures. Do they look too good to be true? Look at the effect size. Is it impossible? Then look at the meta-analysis. Does the meta-analysis indicate a summary of the entire literature? Does it seem to have a good balance between published and unpublished? Does it have some measures of publication bias? Does it have some adjustments with simulating things that are not in there in order to see Pete, Peace, Eger, and all of this in order to see what happens when we compensate for simulated studies? Are there mass replication efforts? Did they try this again and again? Where? Look at all the results. So before you embark on a study, before you believe something, before you follow up on something, before you invest years of your time in order to follow up some flashy findings, you need to ask yourself, what is it that I can do when I read the paper in order to assess whether this is credible or not? 2010, there was nothing that you can do. Some intuitions, you needed a statistician. Nowadays, you've got StatCheck, eCurve, Shiny apps for you to be able to take an entire literature, put this in, and get some kind of an indication. Even if you know nothing about a meta-analysis, you don't know what a p-curve is, there's some tools that are going to help you to do this automatically, that you can make an assessment within half an hour. Half an hour is a good investment for you to make sure that you're not wasting years ahead doing all that. What kind of studies should you look at? So status quality research that has no pre-registration, has no open data, has no open science whatsoever, barely worth a mention. I really believe in this. This is from Chris Chambers, the person who invented some of the best practices right now, like register reports. If you have something that has open data, it's a little bit better, but still red. If you have something that is pre-registered and open data, open code, a little bit getting to the green. But finally, one of the solutions that you should be talking about in this course is doing a register reports, doing a pre-registration that is sent for peer review. And then hopefully in a decade, we will have a meta-analysis of register reports with no publication bias, with no indication of any questionable research practices, where everything is open. We can evaluate everything. And hopefully we can get closer and closer to continuously updating meta-analysis of the best practices of open science with studies that actually show something that is meaningful. So right now, we're very close to this. Over the last decade in social psychology, we got a little bit closer to confirmatory open science with pre-registrations. In my team, in the last 3 years, we've tried to submit as many as possible register reports. And hopefully in a decade, in social psychology, we'll get to a point where we're getting close to being able to say something to policymakers and making sure that there's no indication for anything that can go wrong in all of this process, right? So all the conclusions, finally the summary, and I'm gonna stop with this. This is the last slide, and we can talk about this. Some people, and could be that Roy Baumeister is one of them, they look at all this and like, what are you talking about? All of the things that you're talking about are no indication for a crisis. And I'm saying, that's fine. We can have a discussion about this, but the way that I view open science, pre-registration, shiny apps that look at quantification of a literature, or having an assessment, or talking about this in classes like this one, is that it's a bit like with the climate crisis. People are saying, is there global warming or not? So we're talking about green jobs and livable cities and renewables and clean air and water, and then people saying, what if this is all a big hoax and we create a better world for nothing? So I'm talking, in terms of science. improving the use of all kinds of tools, preventing p-hacking and fraud, increasing transparency, performing all kinds of applications in order to see that everything is credible. And then some people come up to me and say, but maybe you're wrong, there's no crisis. What if this is all a big hoax and we create a better science for nothing? So my main point is like, let's just understand where we are. Let's talk about things and create a better science, regardless of whether you believe that this is true or not. Yeah. So lots of people now agree with me, UNESCO, NASA, G7, all of these things talking about open science. And I guess this is what you're here to do in this course. So I'm just going to leave this out there. And I'm very curious to hear like your impressions, answer your questions, whatever is on your mind. For as long as we have after class, you can write to me. Just tell me what you think, what kind of things come to mind, and we can talk about that.
What motivates you to still work on psychological science after you've experienced it actually in your own skin? You experienced this crisis. You were in the middle of the most notable events of the replication crisis, and everything collapsed. So what is your motivation that makes you to stay with psychological science? Because from this point of view, like most of it sounds like nothing, right? Sounds like bullshit.
Yeah. So I honestly don't know. I don't know what works and what doesn't work. I know that ego depletion and social priming, at least in my view, don't work. But I really wanted to know, are there things that do work? So should we just toss everything aside and say psychology is bullshit and we shouldn't do anything? Or perhaps there's something that is reliable. So one of the things that I decided as a postdoc, I'm going to put all of my research aside, and I'm going to try and look at the literature. And I'm going to use things like the p-hacker and the p-curve and all of that in order to see what do I think is the strongest literature in social psychology. And at least in my view, because I gave a lot of courses in many places around the world, in the Netherlands, in the US, in Hong Kong, in Taiwan, things that seem to come out are things that had to do with decision-making. We're talking Kahneman and Tversky, prospect theory, loss aversion, framing effect, anchoring effect. At least in my intuition, I thought these might be more reliable, but I don't know. How would I know? So with my team at the University of Hong Kong, with all of my students, as early as second-year undergraduate, we started to systematically map judgment and decision-making. And what we found is that some things don't work, but many things work. And sometimes they work even better than intended, or sometimes if you update them, they work in a meaningfully different way to what was originally published. And I like this because it allowed a sense of a little bit more optimism. And not everything is overhyped. Not everything has been done with these kinds of problems, but there are some literatures that are a little bit more solid. So what makes decision-making better? What's nice about Tversky and Kahneman is that they started with very simple demonstrations. It's a vignette. So typically in the article, instead of very complicated methods that you have no idea what happens in there, there's a vignette. You can read the vignette. You can show this to your parents, and they'll immediately understand what the decision is. And most of these effects, like when you show this to people, what is it that they tend to choose? And then you show them the correct answer. Most people are like, huh, I've learned something new. I know something about myself. And indeed, there is an indication that I'm biased. So many of these effects seemed very, very solid at the beginning based on gut intuition. But now that I've done this for 7-8 years, I know that a lot of these things tend to be quite credible and good. Now my next challenge is saying, okay, so I'm able to demonstrate this in the lab. Am I able to demonstrate this in the field using some kind of nudging techniques or what So this Sunday, I'm flying out to Nairobi, to Kenya, because I want to see when we work with policymakers and behavioral scientists and people who are in the field, are we able to translate what's happening in the lab to the field? Now, when I came in 2009 to do a PhD, I thought all of this is going to be done. I wasn't expecting that I will be the one that needs to do this kind of thing. So that's a little bit frustrating and disappointing, but it is important because if there is something that we can do in order to help these people in the field and contribute, science can do a lot of good things for people. So I want to be part of that. This is why I came into science. So I see myself as giving tools to people to evaluate what seems to be credible and what isn't credible. So don't go in ego depletion, social priming, but in decision-making, there's some stuff that seems to hold pretty well. To what extent, how far can we go, what can we do with this in the field? It's up to us to figure out. I don't think that I will live long enough in order to see science becoming the science that I wanted to see, but hopefully you will. So it's up to you to carry the torch and do the right things with science. So we failed you. We should have given you better science. But hopefully we're starting to clean the act. So by the time that you finish your studies, MA, PhD, whatever you're doing, hopefully by that time you'll get to a field that is doing much better than the field that I came into doing a PhD. That's my hope, So I want to be part of that if I can contribute to this in some way. I have some hope that over time they will see the positive things that come out of all the tools that we offer and all the rethinking and reassessment that we're offering.
How do we carry the torch, so to speak? So like, how do we bring open science to the masses?
Then go ahead, carry the torch. So if you're a student, do pre-registrations. I do all of the theses that are with me. We submit as registered reports. Everything that I do is open science. If you're in a lab and your lab doesn't do this, ask your PI, why don't we share everything? What's preventing us? What are the implications of not sharing everything? Is this going to harm something down the road? When we see somebody else who doesn't share, what do we think about this? So sometimes the only thing that you can do is ask questions, and then hopefully with some time, practices will emerge. 10 years ago, it was almost impossible to do open science. You didn't know how to share, you didn't know how to do pre-registrations. Register reports just started to come out. Nowadays, we have amazing tools, to overcome such things. So I'm a little bit more optimistic. Still lots of challenges. It's going to take another decade. But at least in social psychology, cognitive psychology, I feel like good things are happening. The big editors in psychological science, JPSB, AMPPS, all of the big journals in social psychology are now having editors who care about open science and are promoting open science. 10 years ago, this seemed impossible. Now this is a real thing. But sometimes it's difficult to stay optimistic. But over time, when you look back at what we've done the last 10 years, I'm proud of the students and what they've been able to achieve. So I just need to keep at it. Hopefully in a decade or two, things will be better.